So we're dealing with, just took a few examples and five integration only for now. Just chose a few. So let's take the first one. So here it says, determine the integral of y dx. But when they give you the question, it's in terms of y. Can you see that? So y is equal to tan root x divided by root x. So now, you are putting in your integration sign there. Can you see that? So you're going to make integral of y dx. But what is y? It's tan root x divided by root x. So you're going to make integral of y, which is tan root x divided by root x dx. Right, so now, it's clear, you must have an integration sign and you must have either dx if you're integrating with respect to x. Now be careful, this is not integration by parts. Okay, if you look at here, you've got tan of root x. If I rewrite this here, let's see what will it become. So that's going to be tan, and that is x to the power half. Can you see that? And this square root x, if I take it to the top, it's going to become times x to the power minus half. Now what do you notice? That you have an x to the power half, and you've got x to the power minus half. So we are dealing with an example where you've got the integral of tan f of x multiplied by f prime x dx. So f prime x is the exact derivative of f of x. Okay. So whenever you have an exact derivative, you always let u equal to f of x. In this case, your f of x, the f of x here is x to the power half. You're clear with that? So now, when you differentiate du over dx, the derivative here will be half x to the power half minus 1, which is minus half. Now, you can go and simplify further, yeah? But I'm not going to go and simplify because this is not simplified. Right, so I got my x to the power minus half, and I see there's also an x to the power minus half. So let me manipulate this equation. So therefore, dx is going to equal to du all divided by half times x to the power minus half. Okay, so now, if I substitute here, so that's going to be tan of x to the power half, which is u, times x to the power minus half, times your dx there, which is du all divided by half, times x to the power minus half. You can see that? So now it's clear, whenever you have the exact derivatives, they must cancel there, so you can see that and that will cancel. So what remains? What remains here is, be careful, that divided by that is 1. So there's a 1 on the top and there's a half in the bottom. You can see that? 1 on the top, half in the bottom. And then you have tan u du. So now, what is 1 divided by half? 2. It's 2. So that's 2 times the integral of tan u du. And now, this is a standard integral straight from your formula sheet. When you integrate tan, it's going to be ln absolute value of sec u plus c. So that's going to be 2 ln absolute value of sec. What was u? U was the square root of x, so x to the power. So it's an exact derivative problem. Can you see that? It's of this type. So this is just one example. You could have had sine f of x, f prime x, cos f of x, f prime, anything from your table. Okay, don't rush and try and use integration by parts when it's not. Okay. Okay, let me deal with the second one. That's 4.3 minus 4. So we have the integral of x to the power n times ln x dx. Okay, I'm just going to move on with the examples because we've got a lot to do here in a short period of time. Alright, so now, here, this is integration by parts because I have a ln x here, and if I differentiate ln x, it's not going to cancel. If I differentiate x to the power n, it will not cancel. So this is integration by parts. So what is the formula for integration by parts? It is f of x times g of x minus the integral of g of x times f prime x dx. So now, you go to your priority list. Remember your priority list. And you choose f of x. So, from your priority list, number 1 is your inverse trig function. Number 2 is log, so ln. So, f of x has to be ln x. So, therefore, g prime x is going to equal to x to the power n. Right, so what do we need to do here? We need to find f prime x. Let's find f prime x. The derivative of ln x is 1 over x. Then we also need to find g of x because g of x is part of the formula. So this is g prime x. So to get g of x, I need to integrate x to the power n. Okay, so n is defined as a constant, it's a number, so therefore it's going to be, how do we integrate this here? This is going to be n plus 1 all divided by n plus 1. Now we substitute. So my f of x is ln x, g of x is x to the power n plus 1 over n plus 1 minus the integral of the same g of x, which is x to the power n plus 1 over n plus 1 times f prime x. The f prime x is 1 over x dx. Now, we need to simplify this part. Remember, n plus 1, those are just numbers, constants. So, I got my ln x times x to the power n plus 1 over n plus 1 minus, let me take the constant and write it in front here, so that's 1 over n plus 1. So I have x to the power n plus 1 on the top, and what do I have at the bottom? It's just x to the power 1. Okay, so now, we need to simplify this here. Right, so we know from our exponent laws, going back to exponents, when you have x to the power a divided by x to the power b. So when we are dividing and the bases are the same, we write down the base one time and then its top exponent minus bottom exponent clause. So you can see we have the same situation. You write down the base once. Your top exponent is n plus 1 minus your bottom exponent is 1. So what remains? Just 1. Okay, so it's just like going back and integrating the same thing. Can you see that? Now we can integrate. So all you're doing is you're integrating x to the power n, which is x to the power n plus 1 over n plus 1. If you're done now, there's no more integration. Plus c. Let me just simplify this here. And that's going to be x to the power n plus 1 times ln x over n plus 1 minus, we got n plus 1 times n plus 1 in the denominator, which is n plus 1 all squared times x to the power n plus 1 plus c. So that was integration by parts. So there is one like this in the textbook, but it came out also in the exam. You can see this. Alright, so the next one. We need to integrate x divided by 1 plus x to the power 4. Okay. So the numerator is not an exact derivative of the denominator. You see that? But now you need to be careful. If we go back to differentiation, remember if I say y is equal to inverse tan of f of x, these are your inverse trig functions, then dy over dx, the formula is f prime x all divided by 1 plus f of x all squared. That is the formula to differentiate inverse tan. So, if I give you y is equal to inverse tan of x, so I'm replacing f of x with x now. So then, the derivative here is going to be f prime x, which is 1 all divided by 1 plus f of x, which is x squared. So that's differentiation. So if I ask you to integrate 1 over 1 plus x squared, the answer will be inverse tan. Let's work backwards. So what happens if I give you y is equal to inverse tan of x squared? Y is equal to inverse tan of x squared. So now what's happening? F of x is being replaced by x squared. So therefore, the derivative, okay, the derivative here, derivative of x squared is going to be f prime x, which is 2x all over 1 plus f of x, which is x squared all squared. Can you see that? So now, if I simplify this here, it's going to be 2x all divided by 1 plus x to the power 4. Look at this example. It's just that this one has the 2. So if I take the 2 and write it in front here, it's almost the same. You can see that. So now, how do you get from here all the way? You can do it by inspection if you write it down like this. Okay, but let's see how we're going to do it by using U substitution. So now, by using U substitution, I got my x there and I have 1 plus x to the power 4 can be written as x squared all squared. Okay, you can see that. So now I can see the numerator is a derivative of x squared. It was not a derivative of x to the power 4, but it was a derivative of x squared. Can you see that? So I can let u equal to x squared. So then du over dx, the derivative of x squared is 2x. So if I make dx the subject, dx is going to equal to du divided by 2x. So let's see what happens now. So I've got x on the top and then I've got 1 plus x squared. But x squared is u squared. U squared. Can you see that? What is dx? dx is du divided by 2x. So now it's clear that you have x on the top and x in the bottom. They cancel. So what remains? Let's take the constant. The constant is 1 over 2. There's my 1 over 2 there. And I have 1 divided by 1 plus u squared du. Okay. So now, when you integrate 1 over 1 plus u squared, if you go to your formula sheet, obviously it's given to you in terms of x. But the fact is, when you integrate 1 over 1 plus u squared, it's a formula inverse, it's an inverse tan of u plus c. Can you see that? It's inverse tan of u. So now, what was u? What was u? U was squared. Okay, here if you go to your formula sheet, what's shown to you on the formula sheet? This here, so let me just write this down. So on the formula sheet, you have the integral of 1 over 1 plus x squared dx, which is going to equal to, sorry, not 1, that will be a squared plus x squared. Okay, so this is going to be 1 over a inverse tan x over a plus c. That's how it's given to you in the N5 formula sheet. Right, they don't have the B here like in the N6 formula sheets. But the fact is now it's the same thing, it's just that here is u. A squared, that's 1 squared. So that's 1 over 1. Okay. Okay. Next one, same paper, November 2018. So this one you can see was not straightforward. You have to remember your differentiation. If you forget the differentiation, then you will not be able to do the integration. You see that inverse trig. Now this one is multiplication. Multiplication, but there's no exact derivatives. If I let you equal to x over 2, it's not going to cancel. Okay, so what is this? This is integration by parts. So let's write down the formula. The formula is f of x, g of x minus the integral of g of x times f prime x dx. So what is my f of x? From your priority list, number 1 is inverse, number 2 is logs or lim, number 3 is cos of x, and we do have it here. You see that? So f of x has to be 3x plus 5. So therefore, g prime x is going to equal to cos of half x. So what do we need to find? We need to find f prime x. So f prime x, the derivative of 3x is going to be 3, the derivative of 5 is 0. And g of x, I need to integrate cos there. So I'm going to integrate cos of half x. And when you integrate cos, it's going to be a positive sine half x all divided by half, which is equal to 2 sine half x. Okay, so let's substitute. So my f of x here is 3x plus 5, g of x is 2 sine half x minus the integral of g of x, which is 2 sine half x, and then f prime x here is 3. It's not a difficult example, you can say that, because now all we need to do is integrate this function. So that's going to be 3x plus 5 times 2 sine half x minus 2 times 3 is 6 times the integral of sine half x dx. Okay, all I have to do is just integrate sine. So when I integrate sine, what do I get? Minus cos half x all over half plus sec. So here remember this is minus 1 divided by half, which is the same as multiplying by 2 there. So it's going to be minus and minus, it will be plus 12 cos of half x plus sec. So this was integration by parts example. Now the next example, I'm just moving to the next paper. It's an old exam paper, 2004. Right, but how do we integrate something like this? Then integration by parts. Can you see that? Because it's multiplication. So it's going to be f of x times g of x minus the integral of g of x times f prime x dx. So here my f of x from the priority list, f of x is ln x. So therefore your g prime x is x squared minus 3x to the power 4. So f prime x, the derivative of ln x is 1 over x, and then g of x, we need to integrate x squared minus 3x to the power 4. So when you integrate x squared, it will be x to the power 3 over 3 minus 3x to the power 5 over 5. And then substitute. So my f of x is ln x, then g of x here is x cubed 3 minus 3 over 5 x to the power 5. And it's f of x, g of x minus the integral of g of x, which is x cubed over 3 minus 3x to the power 5 over 5 times, now times by f prime x here, which is 1 over x. So, what are we going to do here now? We need to remove these brackets here and simplify using our exponent clause. This is like how we simplify this example here. Remember? So now, this is going to be then x, and then we have x to the power 3 minus 3 over 5, x to the power 5 minus. Okay, now I'm going to multiply. So I'm going to multiply here, it's going to be x cubed over 3 times 1 over x minus 3 x to the power 5 over 5 times 1 over x. Now clear with that? So now, we just copy this down. Okay, so now you can see we are dividing and the bases are the same. So we write down the base once, subtract top minus bottom. So this is going to be 1 over 3 x squared. Here this is going to be minus 3 over 5. That's a 5, that's a 1, so that will be x to the power 4. Simplification involved, you can see that. And finally, we can integrate. So when we integrate this, what do we get? So I'm going to integrate x squared, so it will be x to the power 3 over 3. It's already a 1 over 3. So it's going to be x to the power 3 over 9. Clear with that? When I integrate this, this is going to be x to the power 5 over 5. And there's also a 5 here. See that? So that's going to be minus x to the power, so minus 3x to the power 5 over 5 times 5, which is 25, plus c, you're done. Again, main thing is you integrate this. You don't have to go and simplify and remove brackets, unnecessary, because nothing is going to cancel. Okay. So then what's that? 4.1.1. Now, next one. This one is from the same exam paper. So, it's unlikely that they will give you 2 integration by parts in the same question. Okay, 2 integration by parts problems. So, it looks like integration by parts because it's multiplication. Can you see that? But, check it out. This is an x squared. That's an x. It's a derivative. Not 100%. But the fact is, the derivative of an x squared is definitely an x there. The derivative of an x is a constant. So you must try out the substitution and see if it works. So this is the part. So what we can do is, let u equal to 4x squared plus 2x. So therefore, du over dx, the derivative of 4x squared is 8x, the derivative of 2x is 2. Okay, so now if you look at it, we are expecting this to cancel with this here. It does not cancel when, obviously I need to make dx the subject, but the fact is now, what can we do here in order to get exactly 4x plus 1? I can take on a common factor. So my du over dx, if I take out 2 as a common factor, I'm left with 2 times 4x will be 8x plus 2 times 1 is 2. And now it's going to work perfectly. You can see that? So dx is going to equal to du divided by 2 times 4x plus 1. And now we can substitute. So we got the 4x plus 1. We have sec squared, and this is replaced with u. And dx now we can see the dx is replaced with this here, which is du divided by 2 times 4x plus 1. So you can see 4x plus 1 and 4x plus 1 will cancel. So you end up with just half there, and you're integrating sec squared. Now remember, on your formula sheets, they don't give you directly the integral of sec squared. You need to work backwards from differentiation. So what did you differentiate in order to give you sec squared? 10. That means when you integrate sec squared, your answer is 10. So that will be half 10 u plus sec. And what was u? U was 4x squared plus 2x. That was that example. The next one. Right, so here, this comes again similar to this one here. 4.1.3. Differentiation of inverse trig functions. So if you look at this one, and you remember y is equal to inverse sine of f of x. So the derivative of inverse sine f of x is f prime x all over the square root of 1 minus f of x all squared. It comes from your differentiation of inverse trig functions. Okay. So now this is integration. So on your formula sheet, you are looking for the integral of 1 divided by the square root of a squared minus x squared dx. That's what you see on the formula sheet. So all we're doing is we're working back from here to here. So when we integrate this, it's going to be inverse sine x over a plus c. There is no 1 over a like that. Okay. If there was a b, it would be 1 over b, but they don't show you that in the file. So what we need to do is, now remember, I can change this and I can write it as a squared minus u squared du. I can write it as a squared minus p squared dp. It doesn't make a difference. The fact is, I'm integrating with respect to u here. So the answer here will be inverse sine u over a. Instead of x over a, it's just that x is being replaced by u. Okay, now let's see. Why am I showing you this? I need to rewrite this. This is sign substitution, but we're not going to do it the long way. It's only 3 marks. So we're going to use the formula sheet. Right, so we need to rewrite this as a squared minus u squared. So let's see how we do that. So this can be written as 1 divided by the square root of 7 is the same as, how can we rewrite 7? It's going to be the square root of 7 all squared, and 9 is going to be 3x so we just do a simple u substitution, replace 3x with u. So I'm going to let u equal to 3x. So then du over dx, the derivative of 3x is 3. So then dx is going to equal to du over 3. You're clear with that? So now, what happens here? I know that's going to be du over 3, so there's my 1 over 3 there. That's 1 over the square root of 7 squared minus u squared du. You're clear with that? That's why it's actually du over 3, but there's my 1 over 3 actually. So now, it's written my a is square root 7. So we just go to the formula sheet, you copy it down and then you substitute. So that's going to be, don't forget the 1 over 3 here, the formula is inverse sine. So that's inverse sine u over a, so that's u over root 7 plus c. Don't forget to substitute back for u. So what was u? It was 3x plus c. The next one. So here, this looks complicated. You can see that because you got the square roots there. Now, is it integration by parts? So, what we must do is try use substitution. See what cancels. Okay. So, let's say you are not sure. What you need to do is get rid of the division, make it multiplication. So, what you can do is you can write it as you got your x cot of x squared minus 1 all raised to the power half. And if you take this one to the top, it becomes times x squared minus 1 to the power minus half. Now, I'm sure you're recognizing something right now. That this is a u substitution example. It's exact derivative. This is f of x. If you differentiate if you differentiate here, it's a chain rule, it's going to be half minus half. Can you see that? Then you go inside, when you differentiate x squared, you get the x also, which is 2x obviously. But the fact is, this is the exact derivative. This is what we are dealing with. We are dealing with an example. We are dealing with an example like this here. We have cot f of x times f prime x dx. Okay. So if you have cot f of x times f prime x, then you're going to let u equal to f of x. Right, so in a case like this here, you are going to let u equal to, there's my f of x here. Can you see that? This part here, which is x squared minus 1 to the power half, positive half. So when you differentiate it, du over dx, that's going to be half. And you got x squared minus 1, half minus 1 is minus half times the derivative of x squared is 2x, the derivative of a constant, 0. So now, half times 2x is just x, because your 2 and 2 will cancel. Can you see that? So you got x times x squared minus 1 to the power minus half. I can simplify this, but I'm not going to simplify it because I notice this one is also x to the power minus half. If I simplify here, that means I have to simplify here also, which is a double job. We don't want to do that. So this is my du over dx. So now I can make dx the subject of the formula. So dx is going to equal to du divided by x times x squared minus 1 to the power minus. You could have done this by inspection. All the u substitution examples, obviously you can do it by inspection. Right, but anyway, let's substitute here. So that's x times cot. This is u, and this here is x squared minus 1 to the power minus half, and my dx is du divided by x times x squared minus 1 to the power minus half. You can see that. So what happens here? You can see that here x and x cancel, that and that will cancel. So what do we have? We end up with just an integral of cot u du, which is a standard integral. So when you integrate cot, it's going to be then absolute value of sine u plus c. So that's going to be then absolute value of sine. What was u? U was the square root of x squared minus 1 plus c. Right, so now this one. So this one is a bit unusual, okay, because there's no exact derivative here. So if you had something like sine of ln x, and if this was similar to that f of x, f prime x, that's 1 over x, then you could just let u equal to ln x, the derivative of ln x is 1 over x, it will cancel, so you will just end up with sine of u du, which is going to equal to minus cos u plus c, which is equal to minus cos of ln x plus c. But this is a different type of example, okay? Because here, the derivative of ln x is 1 over x. But now, let's see what's going to happen here. So for this example, if I let u equal to ln x, if I let u equal to ln x, okay, let's see what is going to happen. Then du over dx, the derivative of ln x is going to be 1 over x. So if I cross multiply, then x du is equal to dx. Now let's see what happens here. Okay. So now if I do the substitution, I got sine of ln x, but ln x is no more ln x. What is ln x now? The ln x there is u. So therefore this is u, and dx is going to be x du. Can you see that x does not cancel it? So now we go back. We go back to the step where u is equal to ln x. Okay, so remember that ln x, yes, it's here, is equal to u. So our job now is to try, because remember we are integrating with respect to u. So we need to try and get x in terms of u. So if ln x is equal to u, so now this is a log equation. What is the base here if it's not shown? The base of natural logs. This is not log. Ln, the n means natural log. So the base is e. The base of the natural log is e. The base of normal logs is 10. So if I want to make e the subject of the formula, what is e going to equal? Sorry. If I want to make x the subject of the formula, x is going to equal to what? E to the power u. So now we have a substitution. But it's going to be sine of u times e to the power u du. So this is now integration by parts. Okay, this is integration by parts. And this is the special case example. The special case example is where you use the formula twice. So I'm just going to do it quickly here. So this is going to be f of u, g of u minus the integral of g of u times f prime u du. So special case example, it works anyway, but let's just, you go follow the priority list. For my priority list, my f of u is going to be e to the power u. So g of u, this is g prime u. So g of u will be minus cos u. So that's minus cos u. And f prime u is just going to be e to the power u du. So now I got my minus e to the power u cos u. Minus times minus is a plus. And now integration by parts for the second time. Okay, so it's going to be f of u, g of u, minus the integral of g of u times f prime u du. So that's going to be minus, so that's equal to minus e to the power u cos u plus, applying the formula for the second and last time, my f of u now is going to be e to the power u. This is g prime u, so when you integrate cos, it's a positive sign. Sin u, g of u again, sin u, and then f prime u is e to the power u du. So now, remember on the left hand side, what do we have? On the left hand side, we have the integral of, there's a check, e to the power u sin u du. On the right hand side, we have minus e to the power u cos u plus e to the power u sin u, and we have minus the integral of e to the power u sin u du. So integration by parts, special case, after you use the formula twice, what do you notice? That these two are the same. Can you see that? Always. Whenever you multiply exponential times your trig function, integration by parts is a special case where we use the formula twice only. After using it twice, you notice you get back to the question. So now that means I can take this to the left hand side and it will become what? A positive. So if I have one of this plus another one of that, what will that equal to? 2. So then, if I have 2 on this side, then all I have to do now is divide by 2. So I'm just going to go straight to the final answer. The integral of e to the power u. It's not the final answer because we're still going to use substitution. Let me just write it as 2 first is equal to minus e to the power u cos u plus e to the power u sin u. Here was, all I did was take this to the left and you got like terms, 1 plus 1 will give you 2. So therefore, the integral of e to the power u sin u du is now going to equal to 1 over 2 times. So everything divided by 2, it's the same as multiplying by half there. Minus e to the power u cos u plus e to the power u sin u. And you're done with your integration now. So you put down plus c. But now don't forget that the original problem did not have any u there. You need to substitute back. That's minus e to the power u. What was my u? Let's write it down there. Cos of u plus e to the power u sin of u plus c. What was u? U was the next. That's the next there. The next day, the next day, and the next day. a challenging example because you have to use your substitution and then you see you end up with integration by parts. This was the latest exam paper 2019. So